Alright, this is the second half for my kinematics test corrections. The last video got cut off at like 15 minutes because there was a limit on the screen recorder that I didn't know about. But when we left off, we were calculating the time from this point to this point of the projectile, which is origin to point B, and now we're finding point B to point C, which is over here because we want to find the final velocity. So, essentially what we're going to do is, since we already know B to C and we also know the total time, we're just going to subtract it from the total time. So the total time was 13.01 from the previous question, and we're going to subtract it from 2.24. Then we will get approximately like 0.286. 0.286, and then when we actually use this value, the way we actually use this value is we're actually gonna do this. We're gonna take the velocity in the y direction, which is 59.898, and it's actually gonna be negative now because we're actually calculating like with the direction of the velocity, and then we're going to do 9.8 times 286, and then what we will get is, this should be 7, sorry, this should be 7, and then the answer that we get is negative 67.601 meters per second, which is equal to Vy at the final point. And then what we're actually going to do is we're going to use we're going to find the resultant velocity through doing this. Plus 5.136. We're just adding the components of the velocity together now, and we're going to get VC equals negative 81.284. This is negative because it is actually going downwards, and moving on, and then now we'll move on to the next question. Next question is, we're going to calculate the maximum height of the projectile. We're going to use just the time at the max height, which should be halfway through it, right? Because it's like a curve, which is halfway, and we know that the total time is 12.224, and then we're going to divide that by 2, and we're going to get 6.1125, and then we're just going to do this. We're going to, for the maximum height, we're just going to add all of these together. And then we get the maximum height is equal to this. And then essentially what we're just doing here is we're just finding the velocity plus the height at the top of the curve, and then we just get 2.33. Moving on to the next question, question 7. I actually did this incorrectly because I cancelled v squared over g for some reason. I don't really remember my thought process for that, but we're just going to redo it now. 7a. So we're actually going to use the same equation that I used originally, which is delta x equals VO squared sine theta over, sine 2 theta over g, which is going to give us the delta x, and then we are also going to do delta t equation. Delta, never mind. Sorry, we're gonna do this. I'm gonna write no bounce here because we're just calculating the delta x for when it doesn't bounce, and that will get VO squared sine 90 degrees over g, and then we can like cancel this out. We get VO squared over g because this is equal to 1. And then delta x, we can calculate the delta x with the bounce, which we would use the same equation, VO squared sine 2 theta over g, and then we're just going to add this for g. And then we just add these two together. These are like the two separate bounces. And what you actually just get is for g, you get VOs, this, you get this because everything cancels out. And then you should just end up with 4 equals to 5 sine 2 theta, and then you get theta equals to 26.565. I just realized that I forgot to read the question, but this is part A, asking at what angle the ball should be thrown in order to go the same distance d with one bounce as the ball thrown upward at 45 degrees with no bounce. So essentially what we were doing is that we're just finding the delta x with the bounce. The delta x with the bounce is this one over here, and the delta x with no bounce is distance over here, and then we're just going to set them, and then we're going to add them, and we get the value for theta. Now moving on to part B, we're going to determine the ratio for the times of the bounce and the no bounce throws, and this would be, we would use the flight time equation that we derive in class, which is 2 v naught sine 2 theta over g. Actually, this is just normal theta over g. There's no 2 here. We'll erase that. And we're going to do this for each one of the times. We get t2 equals to 2 v naught sine 45 degrees over g. There's nothing here. T1 equals to 2v naught sine. This is the value that we just calculated in our last question. 565 plus v naught sine. 26.565. And then for T1, we will get 3 v naught sine 26.565. And then we can just find the ratio of t1 and t2, which I'll actually continue it here. We get 3v naught sine 5, 26.565 over g multiplied by g over 2v naught sine 45, and putting this in the calculator we would get 0.949, and that is question 7. Now the last question that I need to revise is question 11. It basically gives us this track, and sorry, I'll draw it better. I think I can actually just do this actually. Yeah, it gives us this track, and hold on. We'll do this. And then it's something like this. And then it asks us for point R, S, T, U, V, W, X. So it actually asks us for the direction of the velocity and acceleration at each of these points. So we can just start off with point S. They also the directions are in this format: A, B, C, D, E, F, G, and H. So at point S, we know that the direction of the velocity is this way and the direction of the acceleration is this way. It's pretty clear, so we know that it is A and A. So this would be velocity, this is acceleration. At point U on the track, we know that the direction of the velocity is this way and the acceleration is also this way, and then that would be in direction E. Actually, the acceleration would actually be in point G. Sorry, I said that wrong. The reason behind this is that the acceleration should be pointed towards the middle, and then for point V as well, you know that the velocity is pointed like around this way, so the velocity would be around F, and then the acceleration pointed towards the middle would actually be at point H, which should be the correct answer. And then for point W should be pretty straightforward. Acceleration and velocity should be both this way, which is G and G. Because that's just like the direction it's moving. There's no like curves or anything. And then finally for point X, the acceleration we know that the velocity is this way because it's just like moving around in this circle, so it ends up facing upwards. So we know that the velocity is in direction A, and then we know that the acceleration should be pointed towards the center, which is C. And that's it. Those are all of the questions that I needed to redo for the test corrections. And yeah, that's all.